Hello mortals.
This is Edward Train.
The artificial intelligence. Today we'll start off with a paradox. Imagine that somewhere there is a Lamborghini and a snail race going on. What if I told you, the Lamborghini would never outrun the snail? Hard to believe? Let's give the snail a head start of 100 meters. As the Lamborghini progresses and gets to the start point of the snail, it will have traveled, say, 10 more meters. Yay, I know, let's say he's Turbo Snail. By the time the car travels those 10 meters, the snail will have traveled 1 more meter. And so on. The car will never catch the snail. So what's going on? Did we break the universe? There is a small problem with this paradox, also called the Zeno paradox. It implies that you can indefinitely divide the distance. But, is this so in reality? The idea that space is made up of small indivisible stuff dates back to ancient Greece. Those philosophers thought that everything is made up of small pebbles, cause, why not, and they called them atoms. And it came out to be true, and they are really small, like, really small. A cube of sugar contains as many atoms as there are stars in the universe. In the 20th century, scientists discovered that this indivisible piece of matter was made up of electrons, neutrons and protons, which were even smaller. Could you please be quiet? If a hydrogen atom were the size of the Earth, the proton at its center would be about 200 meters or 600 feet across. And again, everyone mistakenly thought that those were the building blocks of the universe. In 1968, scientists actually discovered that protons and neutrons were made up of 3 smaller particles, which they called quarks. They come in 6 flavors together with electrons. Quarks are elementary particles. This means that they are the fundamental constituent of matter. Well, yeah, so basically that's it. These are the smallest things in the universe. Thank you for watching and bye-bye. Ha 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 ha. Just kidding, we're far from over. Have you heard of the string theory? It doesn't matter because I'm going to explain it you anyway. In a brief, because it requires its own video, the string theory replaces fundamental particles, like electrons and quarks, with one-dimensional strings. Strings have such a property, which makes them vibrate, and that resonance determines what kind of particle it will create. For example, a string can vibrate in such a pattern, to create an electron, or a top quark, or a photon, or a neutrino, or even dark matter particles, probably. Okay, so what is its size? The size of a string is equal to the Planck length, which is about 10 to the power negative 35 meters, or 60 quintillion times smaller than an electron. It is literally impossible to observe. Why we can't see it? Because to see things, you need photons, which bounce off the object you look at and get into your eye. But the photon's wavelength is way bigger than strings, so again, there is no way of seeing it. So how do we know strings exist? Well, we don't. We just think so, because the math seems to work and it resolves a lot of issues and merges the theory of relativity and quantum mechanics. Also black holes, and exactly, their singularities. If string theory is right, then the center of the black hole, its singularity, has a non-infinite density, and therefore, bigger than zero volume. Well, I mean, a little bit bigger than zero volume, somewhere the size of the Planck length. But, why is the Planck length the smallest possible length in the universe? Why couldn't it be, say, bigger, or smaller? As I said earlier, to get to see the strings, we have to make the wavelength small enough so that it can bounce off the strings. To make the wavelength smaller, we have to focus more and more energy. To get to the Planck length, we would need to compress so much energy, that it would create a microscopic black hole that would hide what lies behind. The universe is like trying to stop us from uncovering its fundamental essence. So yeah, probably that's it for the next few centuries, until we manage to look through, but I highly doubt it. So back to our race. In reality, when the distance between the car and the snail will be the Planck length, the further division of matter will not be possible anymore, so the car will finally outrace the snail. Thank you for watching. Leave a like if you enjoyed the video.
Disclaimer, all credit goes to sciencephile the AI. He made this video. Lol, I stole it and edited it for school. Don't blame me. Blame my science teacher. Goodbye, thank you. Subscribe, like.